Now here in problem number 17, we're going to use the general procedure, and that procedure is this. We're going to find the overall LCD, so the LCD of this term, and this term. That's what we mean by the overall LCD. So that LCD is x, right? That x is coming from here. There's a 1 here. We don't need to write the 1, and a 4 here. So we're going to have x times 4, or how about 4x? Now what we're going to do is we're going to write this LCD alongside each one of the originals. This one, and this one. Now if you want to know why we're doing that, go back and take a look at the video on the general procedure. So let's write the LCD right alongside each one of the originals. So first of all, we'll put it right here. That'll give us 4 over x times 4x plus, now let's put it right here, 4x, and then we'll put it here alongside this one. So that'll give us x squared plus 4 over 4 times 4x. And now all of these denominators should cancel, all 2 of them. So let's do this. So we're going to get, what's going to happen here? This x will cancel with this one, and we'll get 4 times 4. So let's just write that. That's going to give us a 16 plus. Now, in this case, nothing cancels. We'll get x times 4x is 4x squared. So we'll write that 16 plus 4x squared all over. Now in this case, these 4's cancel, and we get x squared plus 4 times x. Now I'm going to write it like this. I will write it as x squared plus 4 times x. I'm doing that because I like things in factored form if I can get them. And now in the top, in this numerator, I can factor a little bit, right? We can take out a 4. So let's take a 4 out of here. So I'll do that way up at the top here. I'll take a 4 out. What I'm left with, 4 times 4 is 16, and plus, and then if I take a 4 out of this x squared, I'm left with an x squared over, down in the denominator here, we've got an x squared plus 4 times an x, and in making that cancellation, we are left with 4 over x. And what we're saying then is that this rational expression, this set of computing instructions, can be replaced with this much more compact, much more efficient set of computing instructions. And what I mean by more efficient, suppose you pick a number for x, like if x is 12. You'd have to put a 12 here, a 12 here, a 12 here, do all that computation. You get some number. But over here, this is equivalent to this. All we have to do is put the 12 here. We get 4 over 12, 1/3. Much more efficient. Now let's move on to number 21. We've got this rational expression here, and what we need to do is use the general procedure, and we need to come up with the LCD. So what is the smallest number 5, 2, 8, and 6 all go into? So now this took a little bit of work. I did this on some other paper, but as it turns out, the LCM, the least common denominator here, the LCD, turns out to be 120. 5 will go into 120, 2 goes into 120, 8 goes into 120, and 6 goes into 120. And this is the smallest one I could find. So what I'm going to do now, according to the general procedure, is that I'm going to put that 120 here, 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 and here, right next to all of the originals. So let's do that. It's going to be 1/5 times 120 plus 1/2 times 120 over 7/8 times 120 minus 1/6 times 120. Now, 5 will go into 120 24 times. So we'll get, let's see if we can get it right here, 24 plus, now 2 will go into 120 60 times, and then 1 times 60 is 60 over, now 8, this 8 will go into 120 15 times, and then 15 times 7, I get 105 when I did that on a piece of paper, minus, now 6 will go into 120 times 1, so that's going to be a 20. Now let's add these tops together. 24 and 60 is an 84. I'll do it up here at the top. So we'll get 84 over, and in the denominator we're going to have down here 105 minus 20, which is 85. So we'll have 85, and these are not going to reduce, so there is our result. Now, problem 31, I'm not really going to use the general procedure for this. Look what we've got. We've just got one single fraction divided by one single fraction. How about if we just invert the divisor and multiply? That's going to look like this. 1 over the g plus 4, there's the numerator, and then we're going to multiply this by the reciprocal of this one. So this is going to be g squared minus 16 now is on the top, and the bottom is a 9. Now we're multiplying fractions, right? We've got two fractions we're going to multiply, and we know how to do that. We factor everything in sight and cancel common factors. So we're going to get 1 over g plus 4 times, now we've got the difference of two squares, right? G squared minus 4 squared. So this is the difference of two squares. We know we get conjugates. So we're going to get a g and a g, a 4 and a 4, one's plus, one's minus, over this 9. And now we can see an inefficiency, right? We see that g plus 4 here and the g plus 4 here. So what we're doing is in this original expression here, although we don't see it here, but in the original expression, we're multiplying it by g plus 4, then dividing it by g plus 4. You don't see it here, but you can see it down here, right? You're taking a g plus 4, multiplying, and a g plus 4 and dividing. So let's cancel that inefficiency. I'll cancel that one with that one. And then what I'm left with is 1 times, right, 1 times g minus 4, which is just g minus 4, over 1 times 9, which is just 9. And there's our result.